Hello, welcome back. Sorry about that. So what I was saying was that this is the better way of setting it up because if you change this, you bring the system over here. You can set this to zero because the system, the amount of energy that's absorbed or gained from the system is the same or equal to that absorbed or gained by the surroundings. So when you add them together, adding these together should equal zero, right? Because they're going to be equal but opposite from each other. You don't need to have the negative here because the negative will be decided by the particular situation. So you don't have to worry about having a negative here. So that could be positive. And then when you figure out each of the Q values, that's going to turn out to be either positive or negative based on the information they're giving you. So, for example, if one of the things you're dealing with is a reaction that's happening in a vessel or in a solution in a vessel, then one of the things you're going to have to be given is the delta H, or the enthalpy of the reaction. And that's usually going to be in kilojoules per mole. And they're going to have to tell you if it's negative or positive. If it's negative, then the Q1 is negative. If it's a positive value, then it's positive, right? You have to keep in mind that the delta H, or the enthalpy of a reaction, is going to be kilojoules per mole, right? So if you're trying to figure out what the equation is to figure out the joules, right? Because our Q values are all heat, all energy. So each of these should be some unit of energy, either kilojoules or joules, right? So if I'm given heat of reaction, then that's going to be most likely kilojoules per mole, right? So if I want kilojoules by itself, then I'm going to need to multiply whatever this is. This is the heat of the reaction, the delta H of the reaction. So I'm going to need to multiply this by moles, a number of moles, right? To get rid of moles, to get kilojoules, right? So that means I'm going to have to multiply my enthalpy of the reaction by some number of moles. And so they would have to give me that in the problem. I would have to figure out the number of moles that are being reacted, or the number of moles of reactant that's being reacted, or something along those lines, right? So this would get me this Q value, but then let's say the reaction is occurring in a solution. So they would have to give me information about the solution. And this would be absorbing heat because the reaction is occurring in the solution. The solution is part of the surroundings. So if this is negative, right? So if my delta H of the reaction is negative, then that means the solution is going to be positive as part of the environment, part of the surroundings. So they would have to give me some information about the solution, and then part of that is going to be the specific heat capacity. So they give me the specific heat capacity of the solution, right? And remember that specific heat capacity is going to be in joules per gram per degree Celsius. So I can figure out the heat gained by the solution by taking the specific heat capacity and whatever else they give me. They're going to have, if I see the specific heat capacity here, again, I recognize it's joules over grams per degree Celsius. So again, to get the Q value of the solution, I need to make sure I take the specific heat capacity and multiply by a mass, by a change in temperature to get joules by itself, right? So that tells me that I'm going to have to use mass times the specific heat of the solution times the change in temperature, which is going to be final temperature minus initial temperature, right? And this is the mass of the solution. So that's going to be Q of the solution, which is going to be my Q2, right? So then I'm going to use this equation to find Q of the solution. And then it's the temperature change here that's going to tell you whether my Q is negative or positive. So if the final temperature is greater than the initial temperature, then that means I absorbed energy, and therefore the Q value is positive for the absorption of energy. If my initial temperature is greater than my final temperature, then when I subtract these, it's going to be negative. So then Q is going to be negative. So that's why I don't need to worry about whether I have negatives or positives in here. I'm just paying attention to what the formula gives me. So if the formula gives me a negative number, then I put a negative number. If it gives me a positive number, then I put a positive number. So, so I can set this up as 0 is equal to Q1 plus Q2 plus Q3, and then I figure out what these Q values are. And then based on the information that they're giving me, then I can figure out what formula I need to use to figure out like the Q values, right? And then it might be the case that they're asking me to find a certain mass, or they're asking me to find the final temperature, right? So what I can do is I can then take my formulas and substitute them in for each of the Q values, and I'll have one long equation, and then I should have one unknown that I'm looking for. So it could be a final temperature or a mass of something, and so I solve the equation for whatever they're asking for. So I think this is the best way to do it. You just need to make sure that you're figuring out, you're identifying all the places that you could have a transfer of energy that is given to you in the problem. So again, you could have a reaction occurring that's going to give off heat or absorb heat. You could have a solution that the reaction is occurring in. Again, the solution is part of the surrounding, so you have to take that into consideration. You have a calorimeter that's being involved, so that's going to be absorbing some of the energy. Again, you might have a system where you have ice cubes that are being melted, right? So you're going to need the heat of fusion that's needed to melt the the ice cubes. So you got to take into consideration everything that they're giving you. But if you understand what each Q represents, and you understand how to get the equation or the formula that's going to help you get that Q value, then you can substitute that formula or equation in for each Q value and then solve for the missing part. I hope that's helpful. If you like this video, share this video, share it with your friends, hit the notification bell for notifications for other videos, hit the subscribe button, and make a comment in the comment section so that way you can tell me what you think, and you can tell me what you would like me to do next in another video. Thanks for joining me, and I'll see you next time.